and also that is a sin theta sin phi, cos theta sin phi in y, cos phi will be converted to sin phi, and minus sin phi is converted to plus a phi cos phi. After that, that will be a r y divided by root over x square plus q square, just like this. A x z, that is rho r, that is y z, x z will be y z, rho r root over x square plus y square, that is that's known as rho, and that is known as r in spherical coordinate system, plus a phi x divided by root over x square plus y square, and az will be ar cos theta minus a theta sin theta. There is no other phi is here, because we know in z there is no phi. How can we calculate this? First of all, if it is a Cartesian coordinate system, that means x, y and z. If it is a point that we have to calculate, that is in spherical coordinate system, that means that is r theta phi. So what is r theta phi? First of all, r is the distance between the position vector from the center of the point to the new point, and that is called r. It's known as r. Phi is the angle between how much it has been derived from x axis, and theta is the angle between r and z. So if it is az, so that will be ar cos theta. As we know, the unit vector will be like this. In that position, unit vector will be ar. In phi position, like this, there is a phi, that will be a phi, and in theta position, that is downward, so it will be like that, it is a theta. So in z we can find out ar cos theta and a theta sin theta. R and theta is visible here. So after that we can convert it like this. The second mathematics is the example 2.10, that assuming a cloud of electrons, confined in a region between two sphere of radius 2 and 5 centimeter, has charge density of this. Charge density means that is the rho charge density. Find the total charge contained by the region. So first of all, we have to take the charge density, that is coulomb per meter cube, and integrate the total volume with this. Then we can get the total charge. That means Q is equal to rho is the charge density, rho dV, and this is a three-dimensional rho. As we know, it is in a sphere. That is a sphere, the two radius are there, 2 centimeter and 5 centimeter radius, but there is a point between these, that the charge is situated between these 2 points, this 2 centimeter and a 5 centimeter. It is under this distance, and there are three parts that will be. This integration will be part 0 to 2 pi, that means that is phi, 0 to pi, that is means that is the theta, and 0.02 to 0.05, that means the centimeter. 0.02, if you convert it to the meter, 0.02, if you convert to centimeter, 0.02 from meter to centimeter, that will be r, that is because of the radius, that is the theta, that is the phi. Okay, so that is gonna be the point. And the dv point means how the dv could be calculated. Rho is there, but dv is r square sine theta dr d theta d phi. How that can be counted? First of all, if it is dv, dv, that means there is a vector or the sign of dv in spherical coordinate system. We have to know the property, that is the r sine theta, r dr, r sine theta d theta and d phi. Okay, so from dv to this we have to find out the line vector. The line vector is r dr ar plus r sine theta d theta a theta unit vector. Again, that's a line vector of spherical coordinate system. Okay, last of all, the d phi a phi, d phi a phi. After multiplying these two parts, we can find out r square sine theta dr d theta d phi. So that is the dv. After integrating this thing, you can find out the answer. This is the answer through 2 pi radians from 0 to 2 pi that generates a sphere. We have this. Put the value of rho here, then just integrate it. After integration we will find out this. So that is the end of the mathematics, the basic mathematics, the spherical and Cartesian coordinate systems. That's the gradient of a scalar. That is the math of verification of the divergence theorem. That is given a is equal to ax square and ay xy and az yz. This is the vector. We have to verify the divergence theorem over a cube, that is a cube, and each side is 1, that is 1, that is 1. Each side is measured as 1. That's a cube. Cube is known as all the sides are equal. The cube is situated in the first octant of the Cartesian coordinate system. That means in that point all are positive. Okay, first quadrant. So there will be 6 faces: front face, back face. Front face means this face. In this face, x is equal to 1, x is equal to 1, and ds is equal to ax dy dz is absent. So the front face will be just like this: dy dz ax will be integrated to 0 to 1, 0 to 1. You will find 1. In back face, that means in the other side, x is equal to 0, ds is equal to minus ax dy dz. That is plus ax, that will be minus ax dy dz. The back face ads is equal to 0. So there are other faces too. That's left face, y is equal to 0, dx dz. Right face, y is equal to 1, dx dz. Top face, dx dy az, and that will be half. The previous right face is equal to half. Bottom face z is equal to